Welcome back to Blueprint to Reality. Today, we're tackling an exciting and futuristic topic, floating structures. Whether it's floating houses, offshore platforms, or entire floating cities, the idea of building on water is no longer science fiction. But how do these structures actually float? Let's break it down. The concept of buoyancy. To understand how floating structures work, we need to start with the science of buoyancy. The principle of buoyancy is simple. When an object is placed in water, it pushes aside, or displaces, a certain amount of water. If the weight of the object is less than the weight of the water displaced, the object will float. This is why ships made of steel, which is much denser than water, can still float. They displace enough water to counteract their own weight. For floating structures like homes or platforms, engineers design them to maximize displacement without adding unnecessary weight. This keeps them stable and buoyant. Types of floating structures. Floating structures come in different forms, each with its own unique design and purpose. Let's take a look at a few common types. First, we have pontoon-based structures, which are some of the most common. Pontoons are large, hollow, and watertight containers, typically made of materials like steel or concrete, that provide enough buoyancy to support the structure above. You've probably seen pontoons on small docks or floating homes. Next, we have semi-submersible platforms, often used in the offshore oil and gas industry. These platforms don't rest directly on the surface of the water. Instead, they are anchored below the surface using large columns that extend deep into the water, reducing the impact of waves and wind. This makes them stable, even in rough seas. Lastly, there are fully floating cities, a concept still in development but gaining traction as urbanization pushes land resources to their limits. These cities would combine multiple floating units, connected like a puzzle, to create entire ecosystems on water. Stability and safety. Floating structures have to deal with forces that land-based buildings don't, particularly the constant motion of water. Waves, wind, and tides can all affect a structure's stability. So, how do engineers ensure that these floating buildings don't tip over or drift away? The answer lies in a combination of design and anchoring systems. For pontoon-based structures, the pontoons are spread out to distribute the weight evenly. The broader and flatter the base, the more stable the structure. Additionally, floating structures are usually anchored to the seabed using cables or piles, which prevent them from drifting due to currents or wind. To handle wave movement, engineers design the structure with a low center of gravity and often make use of flexible connections that allow the structure to move slightly with the water. This flexibility helps the structure absorb wave energy without causing damage. Materials and sustainability. When building on water, materials play a critical role. Concrete is one of the most popular materials because it's durable and can withstand exposure to water for long periods. In fact, concrete becomes stronger over time when submerged in water. Steel, fiberglass, and other composites are also used for reinforcement. As we look toward the future, floating structures may become part of the solution to rising sea levels and overcrowded urban areas. They could also integrate sustainable technologies like solar panels or water desalination systems to create self-sufficient floating communities. So, the next time you see a floating house or an offshore platform, remember that it's not just sitting there, it's riding on the principles of physics, smart engineering, and innovative design. As cities push into new territories, water could very well become the foundation for future civilizations. Thanks for listening to Blueprint to Reality. Stay tuned for more insights into the engineering marvels around us.